take the stage.
So once again, I really want to wish you all a huge welcome to this fourth March It Up meetup we prepared for you. So just to introduce myself, my name is Jelena and I'm in charge of the community in Novi Sad hub of Symphony. To be more precise, in Sremska Kamenica. So you can always ping me or Slavica online if you want to hear more about our life at Symphony. But I'm really not the Jelena you're here to see here tonight. You will hear more from Jelena Milosevic, our DevOps engineer, and I believe that you will have lots of valuable info hearing tonight from her. So I'm not alone here today. I have Slavica, my colleague from Belgrade, helping me. So she will further explain how we will do this meetup and how you can also participate from your side as well.
Thank you, Jacko. I'm as Jacko already told, and I think for those who joined us in our previous events, you already know me. I'm community manager from Belgrade Development Center, and thank you for joining us on our knowledge sharing session during March. And generally, we are like nurturing knowledge sharing in our community and internally and externally, and thank you for supporting that. Today, Jelena Milosevic is helping us to do that. She's bringing one specific topic about Jenkins. And before she actually take the stage and tell you what you came here to learn, I want to just ask Jelena, why did you choose this topic? Why do you think that was interesting for the external community?
Thank you. My name is Jelena, as these two already mentioned. And microservices are becoming more and more popular lately, and Kubernetes is something everyone is talking about these days. And whether it's for a good reason or a bad one, but I think still it's important to learn something about it. And one thing also that is interesting is automation, and it's very popular too because we want everything on click to have. And automating everything in the delivery process is crucial, so we can exclude human errors as much as possible. And that is why I think it's important to talk and discuss this. And I chose Jenkins here because it's open source, it's easy to set up and maintain, and we'll see if people agree with me.
Something which ring the bell, actually, what was really interesting to me is that this is not only DevOps oriented topic. You told me when we talked about in a preparation that this is something which can be interesting to engineers as well. Yeah.
Yeah, I think it's interesting for them because that is something they also use, and I think it's good for them to know how that works, behind the scenes, under the hood. And I think maybe if they feel free with their DevOpses, they can even try to change something in those pipelines without us. But at least they can figure out how things work, so they can maybe be better at their job, because it's to read the logs. That's one of the most important things I think in our job, and I think it's very beneficial for them too.
Yeah, so they will just have deeper understanding, and then it will be more complete. Okay, I just have a few more things to mention before you take the stage, because I can't wait to hear your presentation. Guys, just to mention the flow of this event, I think that's important. As I already mentioned, we are really nurturing knowledge sharing, and this is not the event where we want Jelena to teach you something. Actually, we want this to be a full cycle where we can learn from you as well. And the best opportunity for that is our Q&A section. So please use it. After Jelena's presentation, we will have Q&A section, and in our previous experience, we went over the board with a lot of questions, and we really it took a lot of our time, but we wanted that. So I want to see that as well on this event. We have 3 options of communication. One is through our chat, which I can see that already is on fire. Our chat box, you can use it during a presentation if you notice something is maybe not working during the presentation, or that we need to zoom in or something like that. Please tell us or communicate with us. On the other hand, in a Q&A, I would like you to, for technical questions, to use exactly Q&A box. You can type your question. Jelena will check them out and try to answer as best as possible. And also, please don't hesitate to raise a hand. That you will see an emoji of a raised hand at the bottom of your Zoom screen. So if you want to speak up and talk directly about the topic or the question you want to ask with Jelena, please raise a hand. I will allow you to talk, and there's where magic starts. So I don't want to take a lot of your time. Jelena has an amazing presentation that she will share. So Jelena, take the stage. That was one amazing year.
Okay, so just a second. You see my screen, right?
Yep.
Yes.
Okay. Okay. So our team is Jenkins Pipelines for microservices, as you already know. My name is Jelena Milosevic. I'm a DevOps engineer for almost 3 years now, and I work at Symphony Novi Sad. I started with Puppet and AWS, and for some time I used CloudFormation, and now I work with Terraform, Kubernetes, and Docker. And of course, Jenkins is one of the tools I use. So tonight we will be covering what are microservices. I think it's important to start with that. Next, how we deploy them and how we deploy them with containers and schedulers. And the last part is how we put all that in a pipeline. Okay, so what is a microservice application? By definition, a microservice application is a collection of autonomous services. Each of them does one thing well, that works together to perform more intricate operations. Instead of a single complex system, we build and manage a suite of relatively simple services that might interact in a complex ways. These services collaborate with each other through technology agnostic messaging protocols, either point-to-point or asynchronously. So I hope we now know what microservice application is, and we go to how we deploy them. So automated deployments are essential to developing microservices at scale. And that deployment is the riskiest moment in a life cycle of a software system. With microservices, we have an extreme increase in the number of moving parts in a system, and that increases the complexity of deployment. When we deploy a microservices, we face some challenges. And one of them is maintaining stability when we want to face a high volume of releases and component changes. Also, avoiding tight coupling between components leading to build time or release time dependencies, and releasing breaking changes to the API of a service, which may negatively impact that service's clients. And also, retiring services can be a challenge. When we do those automated deployments well, They are based on simplicity and predictability. And what is important here is that a consistent build pipeline produces predictable artifacts, which we can apply automatically to a production environment. What we want to accomplish with deploying microservices and what we want to avoid. Well, we want stability and availability. In an ideal world, the deployment is boring. Not unexciting, it's just incident-free. And there are too many teams, both monolithic and microservice, that experience deployment software as incredibly stressful. But if working with microservices means we're releasing more components more frequently, doesn't that mean we're introducing more risk and instability into the system? Well, no. But first, manual change management is costly. What that means is that traditional change management technologies attempt to reduce deployment risk by introducing governance and ceremony. And changes go through numerous quality gates and formal approvals, and they're usually human-driven. Although this is intended to ensure that only working code reaches production, this approach is costly to apply and doesn't scale well to multiple services. Small releases actually reduce risk and increase predictability. The larger a release, the higher the risk of introducing defects. With microservice releases, they are smaller because the code base is smaller. And that's the trick. By releasing smaller changes more often, we reduce the total impact of any single change. And rather than stopping everything for deployment, we can design our services and deployment approaches with the expectation that they'll face continuous change. Reducing the surface area of possible change leads to releases that are quicker, and they are easier to monitor, and they are less disruptive to the smooth functioning of an application. Automation drives deployment pace and consistency. What that means is that even if our releases are smaller, we still need to make sure our change sets are as free from defects as possible. We can achieve this by automating the process of commit validation with different types of tests, and automating the process of rollout, which is applying those changes in the production environment. This helps us to build systematic confidence in the code changes we're making and apply consistent practices across multiple services. Automation and speed are key factors in evaluation of the suitability of deployment platform for a microservice application. And speeding up a new host should be highly amenable to automation, ideally by the team developing services themselves. And if a significant cost is associated with every new deploy, whether obtaining infrastructure resources or setting up a new deployment, then a microservice approach will be significantly hampered. Now we go to building a service artifact. So what is a service artifact? A service artifact is an immutable and deterministic package for our service. If we run the build process again for the same commit, it should result in an equivalent artifact. So we have this figure, and what we see is that artifact construction, storage, and deployment process. So typically, build automation tools such as Jenkins, in our case, builds a service artifact and pushes it to an artifact repository. An artifact repository might be a dedicated tool. For example, Docker, it provides a registry for storing images, or a generic file storage tool such as Amazon S3. A microservice is not just the code. It usually has many additional parts like our code that is compiled or not, application libraries, binary dependencies, some supporting processes, and external dependencies, for example. So what is the benefit of an artifact? Artifact gives us immutability. And why do we want that immutability? Because it gives us the highest possible confidence that the package we tested throughout our deployment pipeline will be the same as what is deployed in production. What immutability also allows us is to treat our services as disposable, which means if a service develops a problem, we can easily replace it with a new service. And what kind of artifacts we have? So we have a picture here, and it shows three types of services. We have OS packages, virtual machines, and containers, actually virtual machines images. So operating system is where we could use the packaging format of our target operating system, such as apt or yum in Linux. And this approach standardizes the installation of an artifact regardless of the contents, as we can use standard operating system tools to automate the installation process. But there are weaknesses that doesn't work very well for our deploying microservices. And that is that it adds a different infrastructure requirement. What that means is we'll need to host and manage a package repository. And these packages are often tightly coupled to a particular operating system, and they reduce our flexibility in using different deployment targets. And the packages aren't at quite the right level of abstraction, as we still need to execute them in a host environment. So what we get with virtual machine images is that we get mutable, predictable, and self-contained artifacts. That's something I already mentioned. And this immutable server pattern combined with a configuration tool like Packer allows us to store a reproducible base state as a code. Sounds good, right? But we also have some limitations. So images are logged to one cloud provider, for example, AWS, and we cannot transfer them to other providers like Google Cloud provider. And also, our developers cannot recreate the deployed artifact on their machine. And image builds are often slow because of the lengthy time it takes to spin up a machine and take a snapshot. And it's not easy for us to use for a multiple service per host model. And lastly, we have containers. And a container is a standard unit of software that packages up code and all its dependencies. So the application can run quickly and reliably from one computing environment to another. A Docker container image is a lightweight standalone executable package of software, and it includes everything needed to run an application: the code, the runtime, the system tools, system libraries, and settings. What we get from containers is that containerized software will always run the same regardless of infrastructure, and that is important. Containers isolate software from its environment and ensure that it works uniformly despite differences, for instance, between development and staging. And instead of disrupting entire machines, containerization tools such as Docker provide a more lightweight approach to encapsulating an application and its dependencies. We can run multiple containers on one machine, isolated from each other, and they share the kernel of one operating system, and that makes lower resource overhead than a virtual machine. So we see here that containers gives us almost everything we need. So we go to types of deployments. So we need our services to deploy often, and we need to be able to deploy new versions without downtime and to maintain overall application stability. Every service will rely on others to be up and running. So we also need to maximize the availability of every service. We have three common deployment patterns that are available for zero downtime deployments. and those are canaries, rolling deploy, and blue-green deploys. So at the top part of this picture, we have a canary deploy, and what we do here is we add a single new instance into service to test the reliability of version before continuing with a full rollout. This pattern provides an added measure of safety. Provider will add the canary instance to the group and the backend service to begin receiving requests. It'll take a few minutes to come up. The next part is a rolling deploy, where we progressively take old instances out of service while we bring up new instances, and ensuring that we maintain a minimum percentage of capacity during deployment. So we see here that one instance is killed, and we add a new instance, and we repeat this until all instances are updated with the latest version. And the third type is blue-green deploys. I don't have a picture here for that, but maybe I can use these. So we create a parallel group of services, the green set, for example, this the bottom part of the picture, and they run the new code. And we progressively shift requests away from the old version, the blue set, for example, those 3 instances added up. And this can work better than canaries in scenarios where service consumers are highly sensitive to error rates and can't accept the risk of an unhealthy canary. And all of these patterns are built on a single primitive operation. We are taking an instance, moving it to a running state in an environment, and directing traffic toward it. So now we go to talk about containerizing a service. And as I mentioned, containers are an elegant abstraction for deploying and running microservices. And what they offer is consistent cross-language packaging and application level isolation and rapid startup time. In turn, container schedulers provide a higher level, just a second, a higher level, for a higher level deployment platform for containers by orchestrating and managing the execution of different workloads across a pool of underlying infrastructure resources. Schedulers also provide us other tools like networking and service discovery, load balancing, and configuration management. And all that is to deliver a holistic environment for running service-based applications. What is important here to mention is that containers are not a requirement for working microservices. As I mentioned, we can also deploy services using many methods, such as using the single service per VM model. And together with a scheduler, containers provide a particularly elegant and flexible approach that meets our 2 deployment goals, and those are speed and automation. We've all heard about Docker, and it is the most commonly used container tool. And some of the popular container schedulers are Docker Swarm, Kubernetes, and Apache Mesos. And different tools and distributions are built on top of those platforms. And we look at this picture and we see a process of containerizing a service. We have a service code, and with Docker, we package it into a container image and push it to the container registry. Next, we use deploy instructions to tell a scheduler to deploy and operate the packaged service on a cluster of underlying hosts. As we know, a successful deployment is more than running a single instance. For each new version, we want to build an artifact that we can deploy multiple times for redundancy, reliability, and horizontal scaling. In short, what we want to do is build an image for a service, run multiple instances or containers of our image, and push our image to a shared repository or registry. Now we go to deploying it to a cluster. So a container scheduler is a software tool that abstracts away from underlying hosts by managing the execution of atomic containerized application across a shared pool of resources. This is possible because containers provide strong isolation of resources and a consistent API. Using a scheduler is a compelling deployment platform for microservices because it eases the management of scaling, health checks, and releases across a number of independent services. And it does so while ensuring efficient utilization of underlying infrastructure. At a high level, a container scheduler workflow looks something like this. So we look at this picture. We have an engineer who writes declarative instructions to specify which application they want to run. Those instructions go to a master node. The master node executes those instructions, distributing the workloads to a cluster of underlying working nodes. And then worker nodes pull containers from an appropriate registry and run those applications as specified. To an engineer, where and how an application is executed is ultimately unimportant because the scheduler takes care of it. In addition to running containers, Kubernetes provides other functionality to support running applications, such as service discovery and service management. So now we go to pipelines, and we all that I explained until now, we put that in a pipeline. So we look at this figure, and most of the steps in this pipeline should look familiar. First, we have an engineer who commits some code to a service repository. Next, build automation server builds the code. And if the build is successful, the automation server runs unit tests to validate that code. If these tests pass, the automation server packages the service for deployment and stores this package in an artifact repository. Then the automation server deploys code to a staging environment where we can test the service against other live contributors. And if this is all successful, the automation server will deploy the code to a production. Each of these steps in this pipeline provides us feedback to the engineering team on the correctness of their code. So, for example, if step 3 fails, we'll receive a list of failed test assertions to correct. And with implementing this pipeline, we make the process of deployment highly visible and transparent, and that is crucial for an audit trail or if something goes wrong. Regardless of the underlying language or technology, every service we deploy should be able to follow a similar process. And all this can be done with Jenkins, which is why we are here. And once again, I chose Jenkins because it's open source, it's easy to get running, it supports scriptable build jobs, and it's widely used. And I think it's important to use tools that are widely used because you have bigger support on the internet. But unfortunately, there is no perfect out-of-the-box solution for deployment. Any pipeline is usually a combination of multiple tools, depending on both the service's tech stack and the target deployment platform. And we look at this picture, and it shows the components of our deployment pipeline. And this is for Python-specific tools, but as I mentioned, it can be for any other language. So first, we have build process. Here it is with a PyP, or I'm not sure how it's pronounced. So we build it, and next we do the unit test. And when the test passes, we pack it. And here we use Docker build for this. And after we deploy to staging with kubectl, it's shown here with kubectl, but we can also use Helm, which is also a package manager for Kubernetes. And after that, we do manual tests in staging. And if we are happy with it, we deploy it to production. Again, here it is showed with kubectl, but Helm is a very popular tool also. So we now go to configuring the pipeline. So what we see in this picture is that Jenkins application consists of a master node and optionally any number of agents. So when we run a Jenkins job, it executes scripts across these agent nodes to perform deployment activities where we can use command tools such as make or maven or whatever. And Jenkins pulls our code to a folder, which is a workspace for a specific job. And how does Jenkins know what to do? Well, we define our build jobs in a pipeline script, and that pipeline script is a Jenkins file. And then Jenkins executes that pipeline. So how do we write that pipeline? Well, here are two types of pipeline syntax. On the left, we see scripted, and on the right, we see declarative pipeline. And there are some differences here. In scripted pipeline syntax, one or more node blocks do the core work throughout the entire pipeline. And in declarative, the pipeline block defines all the work done throughout our entire pipeline. I will show an example of a declarative pipeline. It is a relatively recent addition to Jenkins pipeline, and it presents a more simplified and opinionated syntax on top of the pipeline subsystems. Ideally, a service deployment pipeline should be declarative, and what that means is that an engineer describes what they expect to happen. So test my service, release it, and so on. And our framework decides how to execute those steps. This approach also abstracts away changes to how those steps happen. If we want to tweak how a step works, we can change the underlying framework implementation. Abstracting these implementation decisions away from individual services leads to greater consistency across the microservice application. So if you want to create a Jenkins job, we can go and click in the UI. But if you want to automate things, we'll do this by writing a Jenkins file. So here is an example of generating a Jenkins job with Jenkins file. And as I mentioned in previous slides, in declarative pipeline syntax, the pipeline block defines all the work done throughout our entire pipeline. And next, we have an agent. An agent specifies where the entire pipeline or specific stage will execute. And the first one says any. And that means any available agent. But if we want a specific agent, we can declare that here. So for that, we can use a label as shown here. Or for example, we can use Docker, and that will execute with a given container, which will be dynamically provisioned on a node pre-configured to accept Docker-based pipelines, or on a node matching the optionally defined label parameter. And after agent, we have stages. And the stage section is where the bulk of the work described by a pipeline will be located. At a minimum, it is recommended that stages contain at least one stage directive for each discrete part of the continuous delivery process, such as build, test, and deploy. We only have here build and deploy, but I think it gives a clear picture. So next, we have steps. And they are the most fundamental part of a pipeline. Basically, steps tell Jenkins what to do and serve as the basic building block for both declarative and scripted pipeline syntax. In the steps part of our pipeline, we can add the part where we build an image, and here we can put bash commands that we want to run, for example, docker build the service. And next, what we want to do is to run tests. And this should be like any other CI job. If the tests are green, deployment can proceed. If not, halt the pipeline. And here we want to provide rapid and accurate feedback on the quality of the change set. And fast test suits help engineers iterate quickly. If everything is green, we want to publish our artifacts, and in this case, Docker container image, so we can deploy it. In the steps part, again, we add CLI commands for publishing something like Docker tag service and tag to deploy, and we can push it with Docker push and with that tag. And with this, Jenkins will publish our container to the Docker registry. Here we can use public or private registry, and it's up to us to decide. We use private registries when we don't want them to be publicly available, and we can use AWS ECR, Google Container Registry, or Azure Container Registry. So at this point, we have tested the service internally, but in complete isolation. We haven't interacted with any of the services upstream or downstream contributors. We could deploy directly to production and hope for the best, but we probably should not do that. Instead, we can deploy to a staging environment where we can run further automated and manual tests against real contributors. And again, in steps part of the deploy stage, we put our CLI commands to deploy to the environment. And here says deploy to develop and uses develop branch, but we can say deploy to production and use our main branch or whatever branch we want to deploy from to production. And now we see here some additional stuff, and this is environment, and the environment directive specifies a sequence of key value pairs which will be defined as environment variables for all steps or stage specific, like here. And depending, that actually depends where it is declared. And we here have a home variable, which leads to varlib Jenkins. So next, we have post. And the post section defines one or more additional steps that are run upon the completion of a pipeline. And we see here success and failure. And so it happens after a pipeline. So if our pipeline is successful, it sends a Slack message with one message, or if it failed, it sends with another message. And there are more conditions that we can use here. And depending on what we need, there is Jenkins documentation that has everything explained very nicely and step by step. And this is just an example how we do Jenkins files. But here, you don't have to send a Slack message. You can use email or whatever. And that is basically, in short, how a Jenkins file looks like. And staging environment should be an exact copy of the production environment, but with less real traffic. And it doesn't need to run at the same scale. Although staging environments are crucial, they can be hard to manage in a microservice application, as well as the source of significant contention between teams. Microservices have many dependencies, and all of which should be present and stable in full staging. Although a service in staging will have past testing and code review and other quality gates, it's still possible that services in staging will be less stable than their production equivalents, and that can cause chaos. Any engineer deploying to a shared environment needs to act as a good neighbor to ensure that issues with services they own don't substantially impact another team's ability to smoothly test and therefore deliver other services. And deploying to production, if a deployment to staging is successful, this is what should happen next. So our pipeline should wait for a human approval to proceed to production. And when we have approval, we'll release a canary instance first. And this helps us validate that our new build is stable when it faces real production traffic. And if we are happy with the performance of the canary instance, the pipeline can proceed to deploy the remaining instances to production. And if we are not happy, we can roll back our canary instance. And rollback works basically the same as it works when you deploy a new version. So you just take out one instance at a time with the latest version and put the version before that. And that is basically it, how a pipeline should look like. And here we see a lot more options for us. It's not just Jenkins. I just chose it because it's my favorite. And it's widely used. And also Jenkins has a lot of plugins for almost everything. And when you need some help, Google has all the answers. And there are a lot of options, and it's upon us to choose which one we want. So that will be it. And now we are up for Q&A.
Okay, thank you, Jelena. So I hope you liked the presentation Jelena gave us, and I will now read some of the questions that some of you sent in our Q&A section. You can always, again, I repeat, raise your hand and ask your question live. But we will start with the questions that we got in our inbox. So the first one is, any tools you use to manage your artifacts, such as JFrog, etc.?
We don't use JFrog. We use Nexus repository, but I know that JFrog is also a good option. So yeah, we use, but in our case, we use Nexus.
Jelena, we also have a raised hand, and that I will now allow you to talk. You can unmute yourself.
Okay, thanks. I just want to say hello to everyone. Great presentation. And I just want to say, when you are doing in, let's say, making Artifactory after testing and everything, how do you check the security vulnerability of artifact? So when it's going to the stage and production, what I mean is actually, you know, everyone knows that we are using from some images, and these images are updated, labels are updated, or commits, and sometimes they use or not use the latest libraries inside the repository. So it's not only our code, it's only some other codes, some other bash scripts. So in the pipeline, when do you do this security vulnerability in pipeline? Thanks.
Thank you. What we can do before going to production, we have a staging environment, right? And there we can check everything. And also while deploying on Jenkins, we also have the logs, and in the logs we can see what's happening. So I'm not sure if I answered your question, but that is the way that you can check up things before it goes to production.
Okay, I hope, does that answer your question, Enver?
Can I answer?
Yeah.
Yes, sure.
Okay. In my previous project, we have something similar in Jenkins, And there is one step more for security checking. That is actually some open source tool or commercial tool, which actually dig deeply inside the Docker file and build an image to see the security. So yes, the answer is okay, we can do that, but I was just expecting what kind of tools, because sometimes we are working in closed environments in big enterprise companies. They have their own solutions, but for the moment, I would like to know, for example, is there any open source or commercial part which will actually dig into our built image container and check for this security before going to stage and production? Thanks.
Yeah, I understand your worries, but to be honest, I'm not really sure. I haven't done something like that, so I cannot tell you which tool you can use. So sorry.
Thanks. Thank you.
Maybe if someone has an experience from our attendees can raise a hand and join our discussion. We actually have two more. Monish Shavad. I'm not sure if I'm saying it right, but I'm allowing you to talk right now. You can unmute yourself and join us.
Thank you. Anyway, the pronunciation doesn't matter. It was a wonderful presentation because I cannot pronounce your names as well. So please. So yeah, I'm just sharing the experience with the previous question. So in one of our project, it was a big scale project. So there we have used a tool called Sonar Cube, SONARCUBE. I don't know, the tool experience was not good for me. I'll just type it down for you. But if you can, search it out, it will be good. For us, it didn't work that well. So I understand there is a bit of a pain for all of us when we go for, security checks and all those things. Yeah, thank you.
Oh, thank you, Manish. So you gave us an answer to the Anwar's question. That's great.
I just shared one of my experience.
Perfect. I see another options in our chat box, sneak.io. Thank you guys. Thank you for sharing your own knowledge. Jelena, we can go now to our Q&A section. I see questions there.
Yes, I'm just trying to choose like the clever ones. So then the next one is, how do you coordinate between devs and ops? What team topology do you use?
Well, I'm not sure if we have a specific topology. What we do is we have a dedicated DevOps to each project, and the DevOps works together with developers. So as a DevOps, I try to help my team as much as I can and to work with them as much as I can. And I try to understand their application that they are making so I can be better at helping them and finding the ways to find the best automation for all of that. So
cool. Thank you. The next one is, how do you handle database changes while deploying and operating a service?
Well, you can use scripts and also put them in scripted Jenkins jobs. So you just use a script to do the migrations, and you can connect to a database. And also, I think it's important to have a person that oversees everything. I mean the pipeline, but I think it can be easily automated, and Jenkins can do that. I know because I did that in on one of the previous projects. So you can use scripted jobs in Jenkins for that.
Cool. The next one, how would you rate GitHub Actions at this moment? Do you think that Do you think that it is mature enough to be used equally to other tools you mentioned?
I haven't used GitHub Actions, so I don't think I have enough knowledge from my perspective to say my opinion about them. But I heard other people's experience, and I don't see that they are very happy with that solution. And I think that it needs maybe it just needs a bigger community and people to try it out, so they can evolve better. So Jenkins is something that exists for a long time. I don't know exactly how long, but there's a community for that, and that's why it's stable enough. So I think that they also need time to be better. So yeah, I think it needs some more time, and also users.
Okay. Do you have any experience with K8s, probs, startup, liveness, and readiness? Any interesting issues in practice?
Can you the K8 means Kubernetes?
Okay.
But can you repeat the question, because I'm not sure I heard everything you said.
Okay, so do you have any experience with Kubernetes probs? So you have startup, liveness, and readiness. Any interesting issues in practice?
Oh, there are a lot of issues with Kubernetes, and I'm fairly new to that. And yeah, I'm using it currently, and every day is a challenge. So I don't know. I think it's important just to start with it, and then you'll get the hang of it. So the more I learn, the more I understand it. And I think the first problem for all of us is that it's pretty abstract. And when you're using it, that's the moment when you realize how things work. So just reading about it, it's not enough. But experience is something that we all need to be better. So I don't know. I had a lot of issues when I started using Kubernetes, so everything was a challenge for me. So I don't know. You just get used to it.
Cool. Any tips with automatic deployment pipelines and mono repos?
Well, I don't have. The tip is test everything. So test everything as much as you can before it's as a DevOps, test everything. So you are sure that your pipeline works. So before you give it to your developers to use, be sure it does the job that you expect it to do. And in my experience, I like to do that with the developers, because together we know if it does the real job. So I know my part, they know their part, and together we can make a good pipeline. So it's important that cooperation. So that's a tip. And for mono repos, I think it's a bit difficult. I think it's easier if you use a repo for microservice, because it's just, as I mentioned, the bigger the code base, the bigger the impact. And if you separate those, I think you're making smaller impacts. And I think that's the easier way. That's just my opinion. That makes things easier.
I think so as well. Unfortunately, we need to end this now, but still we finished the presentation. I hope that you learned something new. This was interesting experience for us. And as well, we have the last but not least event on Wednesday. We are closing the March and our March Meetup campaign with one event coming from our niche development center, our Milica, which will bring another topic in service delivery. So join us on Wednesday, and we hope that we will not have these connection issues.
Yes.
Thanks, guys. Thank you for staying with us. Thank you for being patient, and see you next time.
Yes. See you guys. Thank you.
Bye-bye.
Bye.